lecture, we have learned about intermolecular forces. Okay, so intermolecular forces is the force formed between the molecule, not within the molecule, it's between the molecules. Okay, the forces that are formed between the molecules. So we have three types of forces. Okay, the first one that we have learned was London dispersion forces, and then we also learned about dipole forces, and lastly is the hydrogen bond. Okay, in order for us to determine which molecule will have which type of intermolecular forces, okay, first you have to know whether the molecule is polar or non-polar. Okay, if it's a polar molecule, it will be London dispersion forces that available for that molecule lah. Okay, the only intermolecular forces available would be London dispersion forces if it's non-polar molecule. Okay, but if it is a polar molecule, that means it will have London dispersion forces, dipole forces, sometimes hydrogen bond. Okay, because hydrogen bond we have to consider two rules ataupun two things in order to have ataupun in order to form the hydrogen bond. Okay, so one of the criteria in order to form the hydrogen bond, the hydrogen in the molecule need to be attached to either fluorine, oxygen, or nitrogen. That will be the first rule. The second rule, the same hydrogen, okay, should be attracted to either fluorine, oxygen, or nitrogen. Okay, all right. If these two rules are obeyed, that means the hydrogen bond is formed, can be formed, ataupun dah form. Okay, right. So you have to consider these two rules for hydrogen bond to be formed. Okay, so those are the things that we have learned in yesterday's lecture. Okay, all right. So moving on, strength of hydrogen bond. Okay. The strength of the hydrogen bond decrease with the decrease in the electronegativity value of the atom bonded to the hydrogen atom. So as I mentioned in our lecture yesterday, fluorine, oxygen, nitrogen, these three are the most electronegative atom in the periodic table. And fluorine being the most electronegative, okay, followed by oxygen, and lastly will be nitrogen. Okay, so the reason that the hydrogen bond is considered as the strongest because hydrogen is most electropositive in the periodic table, and that is attracted to any of these three most electronegative atom in the periodic table. Okay, this attraction is considered as the strongest because you have two extreme lah dekat situ Okay, dua extreme condition, the most positive, the most negative, so the attraction is stronger compared to dipole forces and apatah lagi London dispersion forces. Okay, all right, if you were to arrange this the strength of hydrogen bond, okay, of course HF will be the strongest, okay, followed by HO and HN. Okay, because fluorine is the most electronegative, right? The strength, this is arranged in terms of decreasing order of strength of hydrogen bond. Decreasing order of strength of hydrogen bond. So HF is the strongest, HN is the weakest. Okay, all right. Determine the type of intermolecular forces that exist between the following pairs. Okay, all right. Before we could name or we could state the type of intermolecular forces, we have to determine whether the molecule given are polar or non-polar molecule. All right. The first question, is HBr a polar or non-polar molecule? Guys.
Polar.
Polar.
Okay, all right. HBr is a polar molecule. How about H2s? Is H2s a polar molecule?
Yes.
Polar.
Okay, it's also polar. How do you know that it is polar or non-polar? Ini kita kena go back to our polarity subtopic. Our subtopic, polarity, we have covered that how to determine the polarity of the molecule. Maksudnya this is related to polarity lah. Of course, it is closely related. Without you determining the polarity, you won't be able to determine the intermolecular forces correctly. You akan ada kemungkinan salah. Sebab boleh predict lah. Of course, London dispersion forces will be available for both, basically for all molecules. Okay, London dispersion is present for all type of molecule regardless whether it is polar or non-polar. Itu senang. Okay, dipole forces and hydrogen bonding is the one that kita kena be careful of. Okay, alright. So HBr, very straightforward. Okay, after all, we only have two atoms there. This is slightly positive, this is slightly negative. So the dipole moment is pointing toward Br and no one can cancel this dipole moment. Sebab ada satu saja. So it is a polar molecule because this is a net dipole moment. Okay, alright. How about H2s? Okay, before you could proceed to determine the intermolecular forces, you have to determine whether this H2s is polar or non-polar. Okay, you have to start from the beginning, guys. You have to start from the Lewis structure. Okay, kalau Lewis structure, you dah go through all the process, you will end up with this structure. You ada dua lone pair. Saya cut short saya shortcut je terus. This is the Lewis structure. It's the same as H2O sebab sulfur come from the same group as oxygen. Okay, alright. So this is H2s. The first step is Lewis structure. The second step is you have to determine the electron geometry. Okay, the electron geometry is tetrahedral 1, 2, 3, 4. So the electron geometry is tetrahedral. And then the third one is you have to draw the Lewis structure that you have drawn just now in the shape of tetrahedral. So how do you draw the tetrahedral shape? Okay, so you place it lone pair there and then another lone pair here. Boleh place mana-mana, any of these four. Saya nak place dekat sini. Okay, these two. Okay, this would be your lone pair and then here we have hydrogen. Okay, so this is the shape, the drawing for the tetrahedral just now. Okay, the fourth is to name the molecular geometry. The molecular geometry is, what is the molecular geometry for H2s now, guys?
Band.
Yeah, it is band. Okay, all right. If we extend further, okay, we want to determine the polarity of the molecule. Nak determine the polarity of the molecule. We need this drawing. Okay, this geometry. Okay, let's say saya draw balik. Because it depends on the molecular geometry, right? Okay, so this is slightly positive, this is slightly positive, this sulfur is slightly negative. Okay, so the dipole moment is pointing towards sulfur. Okay, so these two, when we combine, we have one pointing this direction ataupun upward and a little bit slanted to the right. Okay, so this dah settle, so kita ada baki. Ada tak orang yang boleh, ada tak any dipole moment that can cancel this dipole moment? No, we don't have any dipole moment that can be used to cancel out this dipole moment. So this is the net dipole moment. So if we have this net dipole moment that cannot be cancelled out, so it is a polar molecule. So kita akan based on this. Ada tak ini? Kalau ada, that is the proof of the molecule is polar. Okay? Alright. So the moment that you have determined this is a polar molecule based on this dipole moment tadi, dah draw, dah tunjuk, baru you can go for intermolecular forces. Okay? Kena lalu all this step in order for you to name the intermolecular forces. It's not as simple, oh, H2s S H H. Oh, linear. Linear. So ni ke sana, ni ke sini, cancel out. Oh, cancel out. It's polar. It's non-polar. So so this is a non-polar molecule. Bukan macam tu Mudahnya hidup begitu. Okay, you kena go back to the Lewis structure and then go through the process for you to come out with the intermolecular forces. Okay? Alright, so that is how you determine the polarity and end up with the intermolecular forces, the type of intermolecular forces present. Okay? Alright, as you can see, both of them are polar. So both of them should have apa? What type of intermolecular forces present for these two molecules, guys?
Hydrogen bond.
Sorry?
Hydrogen bond.
Are you sure? Okay, let's put the hydrogen bond aside first. Okay, let's focus on apa yang wajib ada sekarang ni. Because hydrogen bond kita kena consider the two rules kan. Okay, kita focus on the two intermolecular forces that we have. Okay, what type of intermolecular forces that are present now, since we have determined both of them just now, the polarity of HBr and H2s just now?
London dispersion forces.
Yes. Okay, London dispersion forces. Next, what else?
Dipole forces.
Okay, we have dipole forces because it is polar. Kalau dia tak polar, that means then there is no dipole forces. Okay, so these two should be present for HBr and H2s. Okay, now let's check for hydrogen bond. Okay, does these two has hydrogen bond? Guys,
No.
can it form hydrogen bond?
No.
Yes, it cannot. Yes, it's true that it cannot form hydrogen bond. Kenapa? Syarat, follow dua syarat tu. Okay, focus on the hydrogen. Yes, in the molecule dia ada hydrogen. Okay, syarat pertama, dia obey tak? The hydrogen must be attached to either fluorine, oxygen or nitrogen in the molecule itself. No, dia tak obey dah syarat pertama. Tak obey syarat pertama, automatically that it will not form hydrogen bond. Same goes to H2s. Okay, H2s also cannot form hydrogen bond. Kenapa? Okay, tengok hydrogen, kita check. It's not a problem, kita check. Okay, hydrogen, we do have hydrogen in the molecule, okay? But this hydrogen, syarat pertama dia tak obey because the hydrogen is not attached to any of fluorine, oxygen or nitrogen. So dah tak ada hydrogen bond. Okay, sebab dia tak obey the rules. Okay, so HBr and H2s has only London dispersion forces and dipole forces. That's all. Okay, alright. Moving on to B, Cl2 and CbRF4. Cl2, okay, is Cl2 polar, guys?
No.
Okay, Cl2 is a non-polar molecule. Kenapa? Because they have the same electronegativity. Dia tak ada the positive ataupun negative end. We don't have that for Cl2 because they share the electron equally. Okay, they share the electron equally. Therefore, there is no net dipole moment. This bond is non-polar. Sebab tak ada arrow tu. We don't have that. Okay, alright. So the molecule therefore is also non-polar. How about CbR4? CbR4, is it polar or non-polar, guys?
No.
No.
Okay,
Non-polar.
CbR4 is non-polar. How do you determine that? Kena go through process ni lah. Okay, alright. So you are familiar with CH4 kan? So CH4 is the same as, the shape is the same as CbR4. CbR4 has the same shape as CH4. Okay, you lalu the process, you tak percaya, you start from the Lewis structure. Okay, you akan dapat tetrahedral sebenarnya. It's just that dia Br. It is tetrahedral. Tetrahedral in shape. Yes, the bond is polar. For each bond in the molecule, yes, they are all polar. Because sini dia slightly positive, Br is slightly negative. Okay, all the bond, the dipole moment is pointing towards bromine. Tetapi is the whole molecule polar? Tu soalannya. Dia boleh ada bond yang polar, tapi the whole molecule tu dia polar ke tak polar? Okay, in this case, it is non-polar. Okay, because kenapa dia end up cancel out one another, each other. Dia akan cancel out. Okay, so this, okay, kata this one dengan this one, dia akan ada, when it is combined, we have arrow here. Okay, when this one dengan this one combined, dia ada arrow ke sini. Okay, so these two will eventually cancel out. Okay, it will be cancelled out. So it will become non-polar. Okay, alright. And then one more thing, kan saya ada bagi tahu tips-tips yang nak determine whether it is polar or non-polar. So you look at the central. Is there lone pair present on the central? No, we don't have lone pair. Okay, and then is all dia punya all the terminal atoms are the same? Yes, they are all the same. Kalau they are all the same, meaning that they have the same magnitude ataupun electronegativity values. So maksudnya dia tak ada lone pair and dia ada all the terminal atoms are the same, therefore dia adalah non-polar. Itu yang kalau you guys tak mahir lah dengan this vector-vector ni. Okay, you guys kena tahu the tips on how to determine whether dia polar or non-polar. But still you have to draw ini wajib in order for you to get mark for polarity. Okay, alright. So both of them are non-polar. Ini kita consider what we call symmetry. Dia symmetry, they end up cancelling each other. Okay, alright. If let's say lah one of the Br, so dia CBr4 kan, so one of the Br is now being replaced with Cl. Okay, automatically this molecule will become polar because Cl is no longer having the same electronegativity values as Br. The magnitude is not the same anymore. Macam saya cerita orang tarik saya kiri dengan kanan kan, yang tarik saya dekat kanan is stronger than yang tarik saya di kiri. Okay, alright, it's no longer the same. So I will be moving to the right. Okay, kalau sama saya takkan bergerak. So tak ada bergerak maksudnya there's no direction dekat situ. There's no direction and there's no magnitude dekat situ. Okay, so therefore non-polar lah. Alright, so same goes to I2 dengan CO2. So kalau Cl2 dengan CBr4, these two are non-polar. So guys, what will be the intermolecular forces available for this molecule?
London Depression Forces.
Yes, that is the only intermolecular forces present. Okay, alright, moving on, I2 and CO2. So you have to determine, so I2 is also the same as Cl2. Okay, dia sama je. So this I2 is non-polar. CO2 also is a non-polar molecule. Kenapa? Kena draw baru nampak. So you akan dapat this structure. Okay, dia ada lone pair dekat situ. Alright. So ke sana and the other one is ke sana because this is negative, this is slightly positive, slightly negative. Okay, alright. So dia pointing towards opposite direction, then it can be cancelled out. So this is also what we call symmetry molecule. Okay, alright. So this is non-polar. So C also will have London dispersion forces only. Okay, alright. Macam tu ya, it's not as simple as tengok je tahu unless you have done so many practices, then you can go ahead tengok saja tahu. Tapi if not, you kena go through the process. Nampak macam mudah aja kan, dia macam state aja kat sini kan. Senang aja kan tahu kan. Tapi tak ya, sebenarnya ini proses dia. You kena tahu ni sebab you want the molecular geometry in order to determine the polarity and then only you can go for intermolecular forces. Okay, alright. Okay, identify all type of intermolecular forces between each molecule in the list below. Okay, I give you 3 minutes for you to complete this checkpoint. Okay, question 1 and question 2. Okay, do it now. We will discuss it in 3 minutes time, so it will be 10:26. Okay, kita akan discuss. Alright, jom discuss. Okay, identify all type of intermolecular forces between each molecule in the list below. Okay, nitrogen. Is nitrogen a polar molecule?
No.
Okay, so what type of intermolecular forces available in nitrogen?
London dispersion forces.
London dispersion. LDF.
Yes. Okay, so it's only London dispersion forces because it is a non-polar molecule. Okay, moving on to ammonia. Is ammonia a polar molecule, guys?
Yes.
Yes.
Okay, all right. So it is a polar molecule. All right. So what will be the intermolecular forces available? Come on, guys.
Long diffusion forces.
London dispersion forces, and then
Dipole force.
yes, dipole force. Okay, all right. So one more thing yang we have to consider whether ammonia has a hydrogen bond or not. Okay, all right. So we have to consider that. We have to check. Okay. So saya cut short. So this is how your Lewis, your apa nama tu? your electron geometry and molecular geometry of the molecule. Okay, so the electron geometry is tetrahedral, the molecular geometry is trigonal pyramidal. Okay, it is polar because it has a net dipole moment. So the nitrogen is slightly negative, the hydrogen are all slightly positive. So the arrow are pointing towards nitrogen. Okay, all right. So if these three are combined, okay, they are combined. So we have a direction ke atas dekat situ. Okay, we have a direction upward. So we have this, therefore it is a polar molecule. All right. Okay, so we have London dispersion, dipole, dipole. We have to check for hydrogen bond. Okay, does ammonia have hydrogen bond, guys? Based on the
Yes.
structure here. Sorry?
Yes.
Okay, all right. So yes, ammonia does have hydrogen bond. So we have to check for the two rules. Okay, look for the hydrogen. Yes, choose any of the hydrogen. Okay, let's say I choose this one. So the hydrogen must be attached to any of fluorine, oxygen, or nitrogen. Yes, this bond. And the hydrogen must also be attracted to another externally to fluorine, oxygen, or nitrogen. So assume we have another nitrogen. Okay, we have another ammonia. We have another ammonia here. Okay, so we know that this is slightly negative here. Okay, this is slightly negative. So let's change color to blue. All right, so this attraction from hydrogen, the same hydrogen just now, to this nitrogen is what we call hydrogen bond. Okay, hydrogen ni pun boleh check dengan nitrogen. So it should be between the molecule. The intermolecular forces is between this hydrogen dengan any of fluorine, oxygen and nitrogen, that it is hydrogen bond. Okay, alright. So kita kena check sampai ke macam itu for the hydrogen bond. Okay, jangan gelabah terus nampak hydrogen, oh hydrogen bond. Okay, not necessarily. Okay, so let's check for C, hydrogen iodide. So is hydrogen iodide a polar molecule?
Polar.
Yes, it is polar. Okay, it's the same like HCl, HBr. Okay, so it is a polar molecule. All right, so name me the intermolecular forces, guys.
Dipole, dipole, and LDF.
Dipole, dipole, and London dispersion forces. Okay, does hydrogen iodide has hydrogen bond? Since it is polar kan, ada tak hydrogen bond for this one?
No.
Tak ada. Sebab dia tak obey the two syarat. Okay, alright. So question 2, identify the compound that can form. Sebab dia senang because HI dia evolve only 2 atoms. NH3 dia more. That means you have to draw. So imagine if you have SF5, imagine if you have BRF3. Okay, you have to draw, and then you have to have the dipole moment and whatnot in order to determine the polarity. Okay, so these molecule are what I considered as simple molecule lah. Okay, so please expect the worst lah. Okay, the worst as in the molecule can be complicated than this. Okay, identify the compound that can form hydrogen bonds with water, meaning that can this molecule form hydrogen bond with water? So imagine, so it's between the molecule kan. So we have this molecule HCOOH, and then we have water. So this is water. Okay, all right. For the first molecule, can it form hydrogen bond with water? Guys. Look for the hydrogen. Is either the hydrogen from the molecule itself ataupun the hydrogen from the water itself. Tak kisah. Sebab in order for the bond to be formed, it should be between the molecule kan. So you can check for any of the hydrogen. It's either from the water ataupun from the molecule itself. Do you think this molecule can form hydrogen bond with water?
Yes.
Okay, yes.
Yes.
Okay. The easiest way would be kita target for the hydrogen daripada water lah. So this hydrogen. Check for all the hydrogen, okay? So paling senang kita check hydrogen dekat water tu. So because we know that this hydrogen, yes, it attached to oxygen. Syarat pertama is OB. Okay, so this hydrogen must be attracted to any of fluorine, oxygen or nitrogen. So in the molecule, this is a polar molecule. Okay, nampak tak dia tak symmetry satu, tapi you have to prove it using, you have to have the geometry and whatnot. Okay, and in the molecule we do have oxygen there. We do have oxygen in the molecule. Okay, all right. So later it will be attracted to the oxygen. Okay, all right. So this is what we call hydrogen bond. This is a polar molecule, guys. In fact, this is your carboxylic acid. Okay, this is a polar molecule. So therefore, this bond is hydrogen bond. Okay, all right. CH4. Can CH4 form hydrogen bond with water?
No.
No.
Cannot. Okay. Yes, the first rule is obeyed. Okay, focus on the hydrogen. Okay, focus on the hydrogen, on the oxygen. Okay, the first rule is obeyed, but the second rule is not obeyed. Okay, dia tak follow the second rule. Okay, because there's no fluorine or oxygen or nitrogen in the molecule. Okay, so this one tak ada, this one ada. How about HF? Ada hydrogen bond tak between HF?
Ada.
Ada.
Yes. Okay, we do have this. Okay, buatlah macam yang hydrogen tadi. Okay, how about this one, the last molecule here? Do you think this molecule can form hydrogen bond with water? Can water form hydrogen bond with this molecule?
Yes.
Yes.
Paling senang adalah kita tengok ada tak oksigen tu, sebab kita dah confirm hydrogen, the first rule dah obey dekat sini. Okay, and then we have oxygen. And for your information, this molecule is a polar molecule. Okay, because all the, dia punya structure dia begini ya. Ini dia tetrahedral, so we may draw it tetrahedral. Kalau saya nak pendekkan, you akan dapat beginilah. CH2, CH3. Okay, sebab dia punya, the dipole moment will be pointing towards oxygen. Sebab oxygen is the most electronegative. So kita combine these two, we have a net dipole moment pointing upward. Okay, alright, it is a polar molecule because this is slightly negative, betul tak? Alright, so we have oxygen there. So this, this hydrogen and this oxygen is considered as hydrogen. Okay, alright. Okay, this is for question 1. This is for question 2. Okay, so the best is to draw the molecule and so that you can see clearly lah. Okay, alright. So this is how HCOOH looks like. This is what we call carboxylic acid. Okay, so it is doubly bonded to this oxygen, and then we have O and then H. Okay, alright. So this is what I have shown to you just now between the H2O, the hydrogen from the oxygen from H2O. So this is the hydrogen bond. So dalam molecule itself, dalam the HCOOH molecule itself can also form hydrogen bond with water. Okay, okay, look for the hydrogen. Cari hydrogen. Okay, cari hydrogen. Okay, this hydrogen, it is attached to oxygen. Okay, ada that possibility. Alright, how about this hydrogen? It is not attached to oxygen ataupun fluorine ataupun N. So this cannot form hydrogen bond. Okay, tak boleh, tak boleh. So that's why you kena check for each hydrogen in the molecule. So this one, dia boleh form. Okay, alright, so this is for HF and this is what I mentioned to you just now, the bulky molecule. Okay, it can form hydrogen with, it can form hydrogen bonding with H2O. Tapi dia itself, dia tak boleh form hydrogen bonding. Okay, imagine this one dengan another molecule of the same molecule, it cannot form hydrogen bonding. But this one boleh. Okay, this molecule and then we have another one, the same molecule, it can form hydrogen bond between the same molecule. But this one cannot. Sebab dia tak ada hydrogen dalam dia. Dia tak obey the rules. Okay, hydrogen semua yang tak sesuai, yang tak obey the rules. Okay, alright, moving on. Okay, so kita kembali balik kepada London dispersion forces. Okay, the strength of London dispersion forces. Okay, we have few factors that can affect the strength of London dispersion forces. Okay, so the first factor is molar mass. Okay, imagine you are given two molecules and you have checked both molecules are non-polar. both molecules are non-polar. So how do you decide which one will have higher boiling point, which one will have lower boiling point? Okay, because both of them are having the same intermolecular forces. So how do you compare? Okay, so one of the factor is based on molar mass. So you compare in terms of molar mass. Okay, alright. Okay, London dispersion forces. So we have example here. London dispersion forces increases down the group 17 and 18. Okay, example, we have group 17 and 18. We know that going down the group, the size become larger. Betul tak? So the size become larger, the number of electron also increase. Okay, and the molar mass also increase. Okay, sebab we know that London dispersion forces is formed due to the movement of electron. So the more electron we have, that means there will be higher tendency for the London dispersion forces to be formed. Okay, alright. So that's why it based on molar mass. Increase number of electron and therefore the molar mass also increase. This is down the group. Okay, so stronger dispersion forces leads to higher melting point and boiling point of the molecules. Right, faham ya? So the higher the molar mass, the stronger the London dispersion forces. Alright, so other than that, the second factor will be the molecular shape. Okay, will be molecular shape. Okay, again, example that I've given to you just now. If you have two molecules, and these two molecules are non-polar and they both have the same molar mass. However, one of them has higher boiling point than the other. So what would be the reason that contribute to the higher boiling point? Molar mass dah sama Dia ada London dispersion forces je after all. So what could be the reason that contribute to the difference in boiling point? Okay, so one of the factor is what we call molecular shape. So molecular shape contributes to the surface area. Okay, all right. Consider these two examples. This molecule have same molar mass, but N-pentane has a higher boiling point than Neopentane. So this is Neopentane. Maybe you can add in. Okay, we don't have apa dia punya nama dekat sini. I don't know on your notes ada ke tak ada, but not in mine. Okay, so you can add in if you don't have. This is Neopentane, this is N-pentane. Okay, all right. As you can see, the shape of Neopentane is more rounded. Dia rounded compared to N-pentane. N-pentane is slightly extended. Dia memanjang. Okay, so as you can see, if these two molecules, okay, this is N-pentane 1, this is N-pentane 2. So the surface area is larger compared to Neopentane. Okay, the more surface area we have on the molecule, the higher the London dispersion forces can act on. Okay, maksudnya dia boleh form more forces dekat situ. Okay, alright. So dia ada higher surface area compared to Neopentane. Okay, there are smaller surface area at which dispersion forces act. Okay, compared to this one. Okay, alright. So that is why this contributes to a higher boiling point for N-pentane compared to Neopentane. Okay, you cannot compare in terms of molar mass because they both have the same molar mass. Okay, so you can compare in terms of the surface area. Okay, right. So please take note that branching enhances the volatility. Volatility is the ability to escape from the surface of the liquid. Naik, jadi dia evaporates. Okay, if there is less dispersion force to hold the molecule, that means it will be easier to be less energy is needed to break the forces and escape. It causes the molecule to escape easier. Senang nak evaporate sebab forces dah kurang dekat situ. Senang nak break lah. Okay, compared to kalau more forces, that means it will be harder for the molecule to escape from the surface of the liquid and evaporate. Okay, that's why neopentane, as you can see the shape, okay, it has more branching and it causes the surface area to become reduced, and this will enhance volatility. It become more volatile. Okay. All right. In terms of polarity, okay, in terms of polarity, I would delete this. Okay. All right. Because we are comparing propane and acetaldehyde. Okay. All right. Propane is a non-polar molecule, guys. Acetaldehyde, on the other hand, is a polar molecule. If it's we are comparing non-polar and polar molecule, so they both have different type of intermolecular forces. If it's non-polar, it only have London dispersion forces. London dispersion forces. If it's polar, then we have dipole forces, London dispersion forces. Then we have to check whether it will have what do we call that, hydrogen bonding point. Hydrogen bond. Okay, so dipole forces is already stronger than London dispersion forces. Kalau dia dah stronger, of course the boiling point will be higher, kan? Okay, because it's the the boiling point is when the energy needed to break the force, okay, for the molecule to become gas. That is boiling point. Melting point is the opposite of boiling point. Dia nak jadi liquid balik. Okay, alright. Yeah. Okay, so itu adalah boiling point. So kalau dia dekat sini, dia punya what do we call that? The type of intermolecular forces are different. So that is the most obvious one lah. Okay, kita tak payah nak tengok in terms of polar. Yes, in terms of polarity, betul. They both have different polarity. Therefore, they both have different intermolecular forces. Okay, they both have different intermolecular forces. So propane is non-polar molecule that has the lowest boiling point. The boiling point and melting point increase with increasing polarity, of course. Okay, so if we compare polar and non-polar, of course the polar molecule will have higher boiling point than the non-polar. Okay, ini kita compare yang biasa-biasa lah. Dia ada condition that we sometimes, even though it is non-polar, but the boiling point is higher than a polar molecule. Other factor that we have to consider. Tapi kita punya ni, kita very straightforward. Okay, kita consider the ideal condition. Okay, just compare in terms of the polar or non-polar. Okay, right. Okay, in terms of boiling point. Okay, in terms of boiling point, as you can see, as the molar mass of, okay, kita compare in terms of group. Okay, we have group 16, the blue one, group 15, 17 and 14. Okay, so 16, 15 and 17, as you can see, dia increasing. Nampak tak? Dia increasing. Okay, this is group 15 also increasing. Okay, alright. So for your information, all these molecule dekat sini, they are all polar molecule, meaning that they have dipole forces and London dispersion forces. Okay, all of them have London dispersion forces and dipole forces. So how do we compare them? Why the boiling point is not the same, even though walaupun dia mempunyai the same intermolecular forces? Okay, so this time around you have to consider in terms of molar masses. Okay, sebab dia punya intermolecular forces dah sama, so we have to consider in terms of molar mass. So as we go down the group, the molar masses increases. Okay, the molar mass increases. So that's why dia increases. Nampak tak? The boiling point increases. Okay, for 16, 15 and 17. Okay, nampak tak? H2O, HF and NH3, even though H2O, H2O come from the same group as H2S dengan H2SE and H2TE. Tapi kenapa H2O punya boiling point is very high compared to the rest? It's because of the hydrogen bond. Okay, nampak tak? HF has higher boiling point compared to dia punya adik-beradik yang lain. Kenapa? Because they are all having hydrogen bond. Hydrogen bond is the strongest. Okay, alright. Okay, so this one group, okay, group 14 ni, cuba tengok group 14. Okay, for your information, all group 14 they are all apa nama tu non-polar. Okay, remember CH4? CH4 is non-polar. Same goes to SiH4, GeH4. They are all non-polar. So the only forces available will be London dispersion force. Okay, London dispersion forces. Tapi kenapa boiling point tak sama? Again, due to molar masses. Okay, due to different in molar masses. So as we go down the route, the molar mass increases. Therefore, London dispersion forces will be apa nama tu stronger lah for higher molar mass. Okay, alright. So itu yang saya dah conclude dekat sini. Okay, you may go through it on your own or later on lah. Okay, alright. Solubility. Right, solubility, polar compound can dissolve in polar solvent. Okay, as an example, ethanol can dissolve in water. Non-polar compound can dissolve well in non-polar solvent. Okay, example, we have example hexane dissolve in CCl4. Okay, all right. In order for the compound to be dissolved in polar compound, in polar solvent, okay, you need to have these intermolecular forces. Baru dia boleh dissolve. Okay, now by right you should have apa nama tu have better understanding on why oil cannot mix well with water. Because water dia polar kan? Water dia ada polar, bipolar means maksudnya dia ada this one. Okay, dia ada negative N dengan positive N. Dia nak form intermolecular forces dengan oil. However, oil is non-polar. Dia tak ada that dipole, negative N, positive N. So how can water form that intermolecular forces ataupun attraction with oil? Dia tak boleh nak form. Okay, that's why dia tak boleh nak mix well. Okay, so in order to mix well, dia mesti ada these intermolecular forces. Baru dia boleh dissolve well in water ataupun dissolve well in the solvent. Okay, that's why non-polar solvent dia gang dengan non-polar compound sebab dia tak perlukan that negative N dengan positive N. Okay, the intermolecular forces can be formed. That is what we call London dispersion forces. Okay, alright. Okay, so we have checkpoint. So we have checkpoint. So please complete this checkpoint. We will discuss it during our lecture on Wednesday. Alright. Okay, so I need maybe 3 minutes. Okay, to explain on what metallic bond is. Okay, so we have this learning objective. Make sure that you covered all of this. Okay, once you have completed this subtopic. Okay, all right. So, what is metallic bond? The term metallic itself means it only present for elements that is metal. Okay, hanya metal sahaja that can have this bond. Therefore, it is called metallic bond. Okay, the Electron C Model is only present for metal, only for metals. Okay, not for non-metal. Okay, metallic bond is the force that hold atoms together in a metallic substance. Okay, metallic bonding results from the attraction between the metal cations and the valence electron, guys. Okay, the concept of metallic bond can be demonstrated by the Electron C Model. So metallic bond, to describe metallic bond, we have a model that is known as Electron C Model. So this is very important, okay? The Electron C Model proposed that all atoms in a metallic solid contribute their valence electron to form a delocalized sea of electron. Okay, look at diagram. Okay, we have a diagram here. All right, we know that metal, they are all solid, betul tak? They are packed very close to one another. Okay, sangat-sangat dekat. So hence we have this diagram. Nampak tak? Very close to one another. Okay, they are very close to one another. Sampaikan the valence electron for each atom tu, they can move around, tahu tak? Dia boleh bergerak sebab dia terlampau close to one another. Okay, so this electron dia boleh bergerak sampai ke sini electron. Okay, same goes to this electron from this cation. Okay, bila dia bergerak, it creates, maksudnya apa nama tu? We know that metal, okay, we have nucleus and it will behave as cations. Okay, alright. When they move around, they delocalize the valence electron. When they delocalize, it creates lautan of electron. Macam merah-merah ni kan. So this is what we call the sea of electron. This is due to the delocalize of electron. The electron dia mobile, okay, dekat this region. But the electron will maintain itself in that region because kenapa? Because we have the cation to hold them in that particular region. Dia tak boleh pergi mana-mana lah. Okay, sebab dia ada the cation. Okay, so the attraction between the cation and the valence electron dekat sea of electron tu is what we call metallic bond. The cation, okay, this cation and this electron and other electron also, that is what we call metallic bond. Faham tak? Okay, so that is the idea of the Electron C model. Okay, and this bond is very strong because we are talking about the cation which is very positive and the electron which is very negative. Bukan macam intermolecular forces just now That one is slightly positive, slightly negative. But this one is memang dia positive. The cation and electron is negative. Okay, so this attraction is what we call metallic bond. Okay, attraction between the cation dengan the electron in the C. Electron in the C electron lah. Okay, is what we call the metallic bond. Okay, so that's the idea of a metallic bond. Alright, so these are the physical properties. Okay, kita dah settle yang the definition of electron C model and metallic bond. So this one kita cover during our lecture on Wednesday. Okay, so kita dah ada tinggal sikit saja, kita boleh wrap up on Wednesday. Right, okay, so I think that's all for today. Tak apa, kita tinggal sikit lagi, we will cover this in our lecture on Wednesday. Berapa kali nak cakap madam ni? Okay, that's all. Any question guys?
No, madam.
Okay, ada ya.